Take a moment and look at your hands. Now look at a mirror. What you see is you, or at least a version of you. But have you ever stopped to wonder what that silvered surface is actually doing? Most people assume a mirror is just a passive observer, a silent witness that bounces light back the way it came. We think of it as a simple bounce, like a tennis ball hitting a wall. But if you look closer, the logic begins to crumble. If mirrors just reflect light, why don't walls? A white wall reflects almost all the light that hits it, that's why it looks white, yet you can't see your face in the drywall. If you hold a book up to a mirror, the text is reversed left to right, but why isn't it reversed top to bottom? Why does the mirror seem to have a preference for the horizontal axis? To understand a mirror, we have to stop thinking about objects and start thinking about the fundamental geometry of the universe. We have to dive into a world where smoothness is a relative term, and where light is less like a ball and more like a collective decision made by trillions of electrons. At the most basic level, a mirror works because it is spectacularly boring. When light hits a rough surface like a piece of paper or your skin, it hits microscopic mountains and valleys. The photons scatter in every possible direction, a phenomenon called diffuse reflection. This is why you can see a wall from any angle, but you can't see a reflection in it. The information, the image of your face, is shattered into a billion chaotic pieces. A mirror, however, is polished to an accuracy that rivals the wavelength of light itself. It is a surface so flat that it preserves the phase of the incoming wave. When a photon hits a mirror, it obeys the law of reflection. The angle of incidence equals the angle of reflection. But that's the textbook answer, and the textbook answer is a lie of simplification. If we want the truth, we have to look at the silver. Most modern mirrors are actually a sandwich, a pane of glass for structural support, backed by a thin layer of metal, usually aluminum or silver. Metals are special because of their sea of electrons. In a piece of wood, electrons are trapped, bound tightly to their atoms, but in a metal, they are free to roam like a fluid. When an electromagnetic wave, light, hits this sea of electrons, it creates an upheaval. The electric field of the light pushes the electrons back and forth, making them oscillate at the exact same frequency as the incoming light. These dancing electrons then create their own electromagnetic wave. What you see as a reflection isn't actually the original light bouncing off. It is a brand new wave, recreated by the metal's electrons in a perfect, synchronized performance. The mirror isn't a wall, it's a rebroadcaster. But this brings us to the riddle of the reversal. If you wave your right hand, your mirror self waves their left. We say the mirror flips things left to right, but does it? If you lie down on your side, does the mirror flip you top to bottom? No, it still flips your left and right relative to your body. The truth is even more unsettling. Mirrors do not flip left to right, they flip front to back. Imagine you are wearing a transparent glove on your right hand. If you pull that glove off, turning it inside out as you do, it becomes a left-handed glove. That is what a mirror does to the world. It pulls the universe inside out like a sock. It takes the dimension of depth and multiplies it by -1. The reason your reflection looks like a person is that humans are mostly symmetrical. We look the same inside out as we do outside in, except for our handedness. When you look into a mirror, you aren't looking at a person standing behind a window. You are looking at a version of yourself where every molecule has been inverted through a fourth dimension of space. It is a version of you that cannot exist in our physical reality, a chiral twin. This leads us to a deeper, more haunting realization about the nature of sight. When you see yourself in the mirror, you are seeing a person who has never existed and never will. You have never actually seen your own face. You have seen photos, which are 2D maps of light, and you have seen reflections, but you have never made direct eye contact with yourself. There is a fundamental barrier between the I who observes and the me that is observed. And yet, we trust the mirror. We use it to construct our identity. We shave, we apply makeup, we check our teeth, all by interacting with a ghost that lives in a depth-inverted world. But what happens when we push this geometry to its limit? What happens when we realize that the smoothness of the mirror is just an illusion of our scale? If we were to shrink down to the size of an atom, the mirror would no longer look like a silver lake. It would look like a vibrating, chaotic storm of probability. The silver atoms aren't touching each other in the way we think. They are held together by forces in a vast emptiness. The light isn't hitting a solid surface, it's interacting with fields of energy. In this quantum realm, the distinction between here and there, between the object and its reflection, starts to blur. We think of the mirror as a tool for vanity, but it is actually a bridge to the counterintuitive. It is a reminder that the world we perceive is a construction. When you see a reflection, your brain is doing the heavy lifting. It sees light rays entering the eye and, following the logic of straight lines, assumes there must be an object over there behind the glass. Your brain creates a virtual space, a mirror world that exists nowhere but in the geometry of your mind. But if the space inside the mirror is virtual, what does that say about the space outside of it? If our eyes can be so easily fooled into seeing a three-dimensional world where none exists, how do we know that our real world isn't just another layer of the same illusion?
To understand why a mirror is a mirror, we have to talk about the frequency of existence. Why is a mirror silver while a piece of gold is, well, gold? And why is glass transparent? It all comes down to a cosmic speed limit and a property called the plasma frequency. In a metal, the sea of electrons can only slosh back and forth so fast. If the incoming light vibrates slower than this plasma frequency, the electrons can keep up. They dance in perfect sync, canceling out the incoming wave and re-emitting it. This is reflection. But if the light vibrates too fast, the electrons are too sluggish to react. The light passes right through. This is why most metals are opaque to visible light, but can be transparent to X-rays. Gold looks the way it does because it's a bit of a lazy metal. Its electrons can't quite keep up with the high-frequency blue light, so it absorbs the blue and reflects the rest, leaving us with that warm yellow hue. A perfect mirror, however, is a master of mimicry across the entire visible spectrum. It reflects everything, and in doing so, it effectively becomes invisible. You don't see the mirror, you see the world's echo. This physical mimicry has a profound psychological parallel. There is a moment in every human life, usually around the age of 18 months, known as the mirror stage. Before this, a child looks at a mirror and sees a stranger, or perhaps a playmate. But then, a cognitive click occurs. The child realizes that the image out there is actually me. This is the birth of the ego, but it is also a fundamental tragedy. Jacques Lacan, the psychoanalyst, argued that this is the moment we become alienated from ourselves. We spend the rest of our lives trying to reconcile the messy, chaotic, internal feeling of being us with that polished, static, two-dimensional image in the glass. We fall in love with a reflection, a specular image that is more perfect, more symmetrical, and more stable than our actual breathing bodies. We become obsessed with a ghost. And as we look deeper into that ghost, we realize that mirrors are our primary tool for traversing time. When you look at the moon in a mirror, you are seeing a reflection of light that left the moon 1.3 seconds ago. When we build massive gold-plated mirrors for the James Webb Space Telescope, we aren't just looking at distant stars. We are using mirrors to capture light that has been traveling for 13 billion years. In that context, a mirror is a time machine. It is a device that gathers the ancient, scattered history of the cosmos and focuses it into a single point of human consciousness. The mirror doesn't care if it's reflecting a smudge on your nose or the birth of a galaxy. It treats all information with the same cold, geometric indifference. But perhaps the most profound thing about a mirror is what it says about the observer. If you place two mirrors perfectly parallel to each other, they create an infinite gallery. The light bounces back and forth, theoretically forever, creating a tunnel that seems to stretch into eternity. But you can never truly see that eternity, because to see it, you have to put your head in the way. Your very presence, the act of observing, breaks the infinity. This is the ultimate lesson of the mirror. It tells us that we are part of the system. We are not objective observers looking at a world out there. We are the lens through which the universe looks at itself. A mirror is just a piece of glass and a splash of metal, but when you stand in front of it, it becomes a portal. It reminds us that the self is a reflection of the environment, and the environment is a reflection of the self. We are the symmetry breakers. We are the ones who look into the inverted, depth-flipped world and find meaning in the reversal. The next time you brush your teeth or fix your hair, look past the surface. Don't just see the person looking back. See the sea of electrons dancing to the rhythm of light. See the front-to-back inversion of a fourth-dimensional flip, and realize that while the mirror shows you what you look like, it can never show you who you are. The you that sees is the only thing the mirror can never truly capture. It is the one thing that remains on this side of the glass, the silent, invisible center of a reflected universe.